Okay, ladies and gentlemen, we're going to start looking at section 3.4. And in this section, one of the very important things that you really need to learn to take with you out of this course is how to write a solution set to an inequality in something called interval notation. Now, I know some of you are very familiar with this notation, but some aren't, and this is a very important thing to learn. What I always tell my students to do, especially if you're new with interval notation, don't just try to go from x is greater than 2 to the answer. Show a graph in the middle. So for example, if I'm trying to graph x is greater than 2, I go to my number line, I put a paren on the 2. Of course, the paren means 2 is not included. So that's what the paren means. It used to be an open circle for you, now it's a paren. And notice that I shade to the right, and I like to write the symbol infinity over this last arrow to let you know that you're heading toward infinity. Now, writing interval notation is pretty easy. You go from left to right. You start with the 2, you put a comma, and you put the infinity symbol. You put a paren on the 2 because it's not equal to 2, and you always put a paren on infinity. Never put a bracket on infinity or negative infinity because a bracket indicates you reached it. So, this notation that my cursor is on is called interval notation. Alright, x is less than or equal to negative 5. This time, because there is an equals, we put a bracket on the number negative 5, which means negative 5 is included as part of my answer. What I teach my students, if you took the top part of the bracket and the bottom part of the bracket and squished them close together, that would say equals. So that's a good way to remember a bracket means equals. And I shade to the left forever, and notice I'm approaching negative infinity. Now, take your graph and turn it into interval notation, reading from left to right, just like you're reading a line of a book. So you're going from negative infinity, comma, to negative 5. Negative infinity will always have a paren because you never include positive or negative infinity. And of course, negative 5 has a bracket because of the equals. Negative 2 is less than x is less than 7. I teach my students that this is called a sandwich. Negative 2 is the bottom piece of bread, 7 is the top piece of bread, and x is the peanut butter and jelly. It's the stuff in the middle. So come over with me to the graph. Negative 2 is marked with a paren because there's no equals. 7 is marked with a paren because there's no equals. And we shade in everything in the middle because that's where the peanut butter and jelly goes. That's where all the numbers are between negative 2 and 7. That's the lunch meat, whatever you put on your sandwich. When I read the answer in interval notation, I look at the graph, and from left to right, I go from negative 2, comma 7, and of course, parens on both. Okay. As we move on to the next example, I have negative 9 is less than or equal to x is less than 4. That means that x is in between negative 9 and positive 4. I put a bracket on negative 9 because of the equal sign. I put a paren on 4 because it doesn't have an equal sign. And x is in the middle, so I shade everything in between. When this translates to interval notation, I'm going from negative 9, comma 4, bracket on the negative 9 because of the equals, paren on the 4. We have an or statement, so let's graph each portion. X is less than or equal to 4. We put a bracket on the 4, we shade to the left, and we put negative infinity over that arrow. X is greater than or equal to 8. We bracket the 8, we shade to the right, and we put infinity. Now, the way we're going to write interval notation here is we're going to do it in pieces. This first piece would become negative infinity, comma 4, bracket on the 4. The second piece would be bracket on the 8 out to infinity. Always remember, read from left to right. And in interval notation, whenever you have two pieces that don't touch, you put a union symbol in the middle. That is a way of saying or when you're using interval notation. So or becomes union. A lot of times in future math courses, you'll hear two disjoint regions. That's just a fancy way of saying there are two regions that do not overlap. And my last example here. X such that -2 is less than x is less than 9. This notation, remember right here, is called set builder notation. And what this basically really tells you is, it's the set of all real numbers x such that they obey this property. Well, if I draw those numbers, I'm between -2 and 9. No brackets, it's all parens because there's no equals. And we end up getting the answer -2, 9 with parens. Okay? If you don't know that notation, you really need to practice it, because when I teach college algebra, for example, and I'm not sure about the 1106 or 1107 because I don't teach the liberal arts courses, but I know for a fact when I teach college algebra, this notation is used a lot, and you need to catch it now, okay? All right, on a number line, highlight the region from 2 to 6. Okay, so I mark 2 and 6. Exclude 2, that means put a paren, don't include it, and include 6, so that means to put a bracket. So I shade in everything between 2 and 6. 2 has a paren, 6 has a bracket. In interval notation, that would be my answer. Paren 2, 6 bracket. Okay, one last problem that we'll work on this video. Determine whether the given values of x are solutions of this compound inequality. Now, the reason this is called a compound inequality, anytime you have two inequalities joined with the word and, or with the word or, that one inequality, which is created by two inequalities with the word and or, is called compound. Just like a compound sentence in English. So, first question, does the number 10 work? Well, best way to find it out is plug it in. Okay, so, let's see here. When I plug in a 10, all right, let's see. This should actually, you're going to have to fix this. You're going to have to fix this here. This should actually say 10 minus 2. Okay, it shouldn't say 8. It should say 10 minus 2. That would become 8 is less than 9. So go ahead and fix that in your notes. This should be 8 is less than 9. And when I plug a 10 into the other part, 30 is greater than 3. Now pretend this is correct. 8 is less than 9. Yes. 30 is greater than 3. Yes. With an and statement, for the whole thing to be true, they both have to be true. So the answer here is yes, the number 10 is a solution. So again, if you'll just make those two corrections on your notes, if you're going, if you're copying them over. Oh, actually, wait a minute. No, I did that okay. I plugged a 10 in here, so let's see. Yeah, this should say 10 minus 2, though. So 8 is less than 9. No big deal, though. It's still true. This is true, which makes the whole thing true. All right, let's look at the number 1. If I plug in a 1, oh good, I did this one right. 1 minus 2 is less than 9. That says -1 is less than 9, so far we're good. When I plug a 1 into the other side, 3 is greater than 3. That's not true. 3 is not greater than 3. In an and statement, if one part fails, the whole thing fails. So this is a resounding no. Okay? All right, and we're going to go ahead and stop here, and then I'm going to pick up the other problems on some future videos.